everyone, and welcome to the kickoff stream of the GPT-4 powered app creation and evals hackathon. In today's kickoff stream, I'm going to be your MC. And let me just share with you the event schedule very briefly. So as you can see during the kickoff stream today, we have a lot of speakers and we will welcome people from TruEra, from Pinecone, from OpenAI. So there are going to be a lot of exciting workshops today. So please keep yourself in the loop and listen to the insightful sessions. So also we will have the few of the sessions during the week, and the submissions deadline would be exactly a week later from now, which is on 23rd. So LabLab, as many of you already know, is a cool ecosystem where you can create your apps, right? Like you can engage in the process of actually working on the things that are inspired by AI, yeah, and following different tech stack. Imagine like your basically idea going to the real world. In today's hackathon, we are going to speak a lot about TruEra and their toolkit, TruLens. This is a toolkit from TruEra. It includes TruLens Eval that helps you to do evaluations and get insights about the LLM-based apps. And with these tools, you can easily promote the better experience of your AI apps that you're going to take care of during this hackathon. So just a quick note before we move to our first speaker. These are the few things that you need to remember during your hackathon participation. You have to register, obviously, on the LabLab AI. You would also have to create the TruEra account to be able to be accepted in the hackathon. And also we're accepting still registrations until Monday. So if you haven't registered yet, be on time and enjoy the hack that we have prepared for you. So with that being said, I'm passing my mic to Anupam, and he's going to, open the curtain to the world of TruEra. Thank you.
Great. Thank you, Katya, and welcome everyone. We are super excited about this hackathon coming together. We have an amazing lineup of GenAI ecosystem partners. In addition to TruEra, we have Logan from OpenAI, who will lead a workshop on GPT-4. We have Roy from Pinecone, who will lead a workshop on retrieval augmented generation with Pinecone. And then Josh Rainey from TruEra on advanced evaluation methods. We also have Portkey as a partner. One of the big things for me personally, before I started TruEra, I used to be a professor at Carnegie Mellon University. I've spent the last decade in this area. And it's incredibly exciting to see this huge wave of folks like all of you here building out applications that can have a positive impact and leveraging tools like the ones we have at TruEra and other our ecosystem partners to make sure that they perform as expected, that you can debug and improve them, ensure that they're of a high quality, and that they are being developed with trustworthiness and responsible adoption of AI from the ground up. That's just incredibly energizing for me. What you have here is also an amazing group of peers. We have over 1,000 folks who are signed up, peers that you can form teams with, learn from, and share your own insights. And the unique thing about this hackathon is as you're building your applications, you'll also learn how to test, evaluate, and iterate on these apps so that they can be production ready. Or in some of your cases, that might also be VC ready if you're planning to launch a startup building on what you end up working on here. We are here to help you learn and be successful. You learn by doing, so please do dive in and engage deeply with the resources we're making available. The 3 workshops today are great places to start. They'll be very hands-on. They'll set you up in the right way for the hackathon. And then finally, we are looking forward to see what you build. One of the biggest things that come out of these hackathons are amazing apps that we had ourselves never thought of. And it comes together because so many people are thinking independently and in groups to build these applications. The last set of hackathons we did with LabLab AI back in December, one was with Google Vertex AI, the other with the new Gemini model. They had over 5,000 participants, and we were just amazed at the end during the judging session to see what came out. And we expect that you'll go even further and do even better. So with that, I welcome you again and look forward to see what you produce. Thank you so much.
Okay, thank you very much, Anupam. Okay, so having that said, we can now move to the walkthrough of the LabLab AI platform. And let me just now stop a little bit on the challenge. So as Anupam already said, like it's really important to use the TruLens Eval during the creation of your app. Basically, that's the most important thing, right, to be qualified for the challenge. As usually, there is also success criteria of the um, of the streaming, yeah, oh, sorry, of the presentation, and you have to make sure that your model is worth enough, right, effective enough, and your app, well, is actually going to be useful out there. Then, of course, presentation, like the clarity, the effectiveness, well, everything plays role in your pitch deck, and it should be really brilliant and attracting attention of judges and others who are doing the decision. So then business value, obviously it should be impactful, it should have some practical aspect and value, and originality. Use your creative side of the brain, be unique, and yeah, just stand out among the others. So with that being said, we also have prepared tutorials for you. You're going to, you can go to LabLab AI tutorials and you can find how you can use TruLens with DALL-E and with GPT-4 Turbo. And we have backed up all of this useful stuff so that you will feel more comfortable while creating your app. And also, I am just repeating again, like what we are fighting for, right? Like what are the hackathon prizes? So they're pretty sweet. For the first place, you get 1200 cash and 1200 in portkey credits. On the second place, 800 cash, 800 in the portkey. And for the third, 500 cash and 500 in portkey credits. So good luck with getting those prizes and revealing your potential in the app creation. These are the mentor leads that are also going to help you and to answer all of your questions that you might have during the hackathon. So now, as I promised before, we're going through the platform walkthrough. So basically, this is a short guide how you're going to land yourself on our website. Yeah, so you have to create or join a team in the LabLab AI. If you already done it, that's great. Then you have to meet your team on the Discord. You can brainstorm, like few concepts, like what you're going to create, or if you have already have some idea then it's perfect. Then you have to communicate with mentors and set it up clearly. Then the most interesting part is actually building your prototype. And the last one, I think, is the easiest, is submission and relief in awaiting of the results. So this is the few types about your profile. So it's really cool if you can, like fill out your profile with as much useful information as you can. So yeah, like please do that. It will be much easier for you for networking purposes, for communication, and etc. Then also you have to create or join your team with the with this button. Yeah, as you can see, you will find it also in the on the website. Um, and as of next step, you will, yeah, like here you see that you can also find the new members to the team, and you can also as a team creator, you can also look for new team members. So basically these are just admin panel of the team leaders and the team members. So I'm pretty sure it's intuitive. You will find that there are a lot of possibilities. As of next step, make sure that you are on the LabLab AI Discord, because, well, this is where the whole fun will actually happen. Also, you have to create a voice channel on LabLab Discord. You can create it there, and please also connect your Discord team to your team, so it will be much easier. And then you can also communicate with mentors, as I mentioned before during the presentation, like they're available all the time. So just please use I need help channel in the LabLab server on the Discord. Then you can also tag mentors on Discord. And yeah, they would be there to help you with any kind of concerns or questions that you might experience. Then, yeah, here the screenshots that we have with the I need help, yeah, and also find the team information about a specific hackathon, AI hackathon. And yeah, coming back to your presentation, again, as I mentioned before, there are certain judging criteria which will help you to stand out and to shine. Well, what can I say? Like, make sure that your project demo is working right, that you have an excellent presentation, that you have a cool project description, that you have everything collected in terms of links, right? Everything is done in terms of all technical setups. And pitch yourself, right? Do your cool video with your presentation, make it short and sweet, no longer than 5 minutes. And yeah, just then wait for the results. So this was it in terms of the walkthrough that we had. In the meantime, we can, I guess, have even like a little break, right? Because now you can also ask some questions if you have in the comments, and we will be gladly to answer them. Okay, so now I will let you guys know that we can also have a little break before our session, so you can make yourself a cup of tea and come back here soon. In 15, we will have an exciting presentation from OpenAI session. And yeah, just again, if you have any questions, shoot them in the chat. If none, then let's just have a small break. Okay, hey everyone again. So now we're continue with our sessions, our fruitful sessions. Today we have a long list of speakers, and I'm very happy to welcome Logan Kilpatrick from OpenAI. Hi, Logan. He's the developer relations from OpenAI, and he's going to lead you through the workshop from OpenAI. So yeah, have fun. And I'm passing mic to Logan.
I love it. Thanks, Katya. Just want to do a quick check. Screen is visible. Folks can see. I don't actually see where the chat is, but I'm guessing folks can see my screen. Cool. Awesome. Is the conversation happening in Lab general chat or the? Oh no, I see. There's a hackathon channel. Cool. Sweet. Yeah. Well, super excited to share. I think there's so much happening in, in the world of AI today, and just to sort of paint the picture of where we are today. Um, Yesterday OpenAI released Sora, which is our next generation, or we announced Sora, haven't released it to the world yet, but it's our next generation text to video model. And I think it really sort of paints the picture of where we are and sort of the trajectory and the arc of some of this AI technology. Like a year ago, things that weren't possible or weren't conceived to be possible are now possible today. And I think that arc of technological innovation is going to continue. And it's super exciting to see, like, as somebody who's building stuff in this space, like these technologies are being built and sort of being made available to folks through APIs and stuff like that, and enabling developers around the world to go and build some super compelling and interesting products. So I'm excited for you all as folks who are sort of taking the step into building stuff during this hackathon. For folks who don't know OpenAI well, it's a research and product company. The research folks do amazing stuff like create Sora. Then the folks on our product team and our applied team actually go and take some of that research and focus on bringing it to the world through ChatGPT, through our API, and we'll talk more about that later on, as well as some of the new API things that we have available for developers. Folks probably know this well, but historically, GPT-4 has been our sort of flagship model that solves problems the best. We announced it back in March of 2023, so it's been almost a year now since GPT-4 came out. At Developer Day this year, we released GPT-4 Turbo, which is the next iteration of GPT-4 with higher context, and a bunch of other improvements. And I share this image on the left just for folks who are thinking about, as you're building, what problems can be well suited by a GPT 3.5 type model versus what problem spaces do you really need GPT-4 for? And again, you can use this sort of as a proxy for some different use cases, but things in the environmental sciences or other areas like that, the GPT 3.5 Turbo model actually does just as good as GPT-4. So I think if you're thinking about like, hey, I need to take this thing and bring it into production, and I'm worried about the costs or the latency of using a larger model like GPT-4, you can actually get pretty much, comparable performance in some use cases using GPT 3.5. You can also do fine tuning on GPT 3.5, which is really exciting, and we'll talk more about that later on. Another thing that I wanted to sort of make mention of for folks is that the vision capabilities that are accessible with our models today are incredible. So we released the vision capability at Developer Day with GPT-4 Turbo. So if you're thinking about like ideas for things that are on the edge of what's possible, I think vision is one of those use cases where there's actually not a ton of investment that's happening from the developer ecosystem. So I'd be curious to see if folks build any vision applications, and I'll try to make it to the award and judging ceremony to see what folks build. But I think there's a lot of opportunity in the vision space, and there's actually like not a ton of competition, which I think is awesome for folks who are trying to build stuff. I made mention of this before, but again, we have sort of two main product service areas. We have ChatGPT, which folks are likely familiar with, and then we have our API. Again, you're here to build stuff, so you're likely thinking about the API. But I also wanted to make mention of the fact that now with GPTs inside of ChatGPT, it can actually be a really great way of sort of prototyping the experience that you're thinking about building. If you want to do, X, Y, and Z use case with vision, and you want to test out some new idea or use case, you can actually build that in ChatGPT to begin with. Make it a GPT. You can actually share it with people. They can use it, and you can sort of do this iteration cycle a little bit faster than you would be able to if you had to like build the product from scratch yourself inside of using our API. And I think that still has its place. Like you still probably want to build stuff with the API, but it can be really helpful to sort of get that iteration loop and that cycle of feedback going a little bit faster than you would be able to in a world without GPTs. So as you're thinking about what to build, it could be a nice way to sort of validate your idea for a hackathon like this. OpenAI has a bunch of different modalities and sort of API offerings. It ranges from like the text all the way to audio and image now. There's a lot of stuff that you can use our APIs for. I think the magic and the thing to think about is that, as you're using all of these different modalities, today they're all sort of different APIs and different models. I think in the future we'll probably have something that sort of brings a lot of this together. That doesn't exist today. So if you're thinking about like, how do I build these multimodal experiences? How do I connect together an audio model with a text model with an image model? The interface for all of those models is text. That is like sort of the layer of connecting tissue that will connect a text model to an image model to an audio model. So really thinking about like, how do you treat that text from a first class perspective and making sure that you're passing around the right information between these different models, I think is really is super important. The sort of second iteration of building a lot of things, or sort of as you ramp up the maturity curve of building with our APIs, the next step that people often want to take is, hey, I have this model that does this, gives me these really interesting outputs. I would love if the model could actually take action for my user, or take action for me in these different use cases, and that's really where tools come in. So with the Assistance API, we have a bunch of tools that are sort of built in, and we'll talk more about the Assistance API later. Things like Code Interpreter, which actually write and dynamically execute code for you and then show you the outputs of executing that code. Things like knowledge retrieval, so that you can do RAG, or retrieval augmented generation, if folks have heard about that before. And also just like simply function calling, which allows you to define in basic JSON schema some structure of a bunch of different functions that you have in your code. And then the model can say, hey, you have a check weather function defined in your code. When the user asks get the weather, because the model doesn't have the capability to check the weather in someone's location by default, it can say, hey, I can't check the weather. Why don't we call this function that you've defined in your code? And then I'll basically give you the function, the parameters to pass to that function. You can pass those parameters to the function, and then you call the function and then give the model the output of that function so that the user can know what the weather is in their location. And that's a really simple example, but functions are really how you sort of enable these long-term agentic workflows. If you want something to check your email and then update your calendar and then maybe send you a text message that says, hey, I did these things for you and you should be good to go. All of that is powered by function calling. So it's really useful to play around. I think it's like one of the foundational components of understanding how to build this technology as you take the step from just text in, text out, or just generating an image and showing users, so like actually building workflows that to me make AI like really useful. Just highlighting some of the recent things that we've put out. So we, at December of 2022, we released the second generation of our embedding models. And then a couple of weeks ago, we released the third generation of our embeddings models, and also an updated GPT-4 Turbo and GPT 3.5 Turbo model. The GPT-4 Turbo model actually has like a slightly newer knowledge cutoff. It has improved instruction following, so it should be a little bit less quote unquote lazy in certain cases. So these models are getting better all the time, which is really exciting. And the new embedding models are so much cheaper that the small model is so much cheaper that it makes embedding use cases like way more accessible now um, to embed. I think it's like 63,000 pages of text costs $1. So you can really like start to scale up massively how much stuff you're embedding and not have to make as many like difficult trade-offs of like, oh, I don't want this information in my database. I only want, this smaller subset of information. You can kind of include everything. And I think it opens up like a lot more like larger scale use cases than were possible before. So it's worth playing around with embeddings if you're interested in those like chat with my documents use cases, or trying to take some large corpus of information that's like not super accessible, kind of hard to understand, and then making it more accessible. I always like to show some information about sort of the historical trends of like who is using AI technology. If you go back, and specifically who's using large language models, if you go back to the end of 2022, it was basically the only people who were using this technology were copywriting AI companies. So the Copy AI, the Jasper AIs of the world. Um, you sort of fast forward 6 months after the release of ChatGPT and some of the new models that we released. It's sort of this massive explosion of basically like everybody is building with this technology, and the order of magnitude of use cases that were possible has increased so significantly. And much of this has to do with like new iterations of models. So going from the GPT-3 era models to the GPT-4 era models. And I think it's worthwhile to keep this in the back of your mind as you're thinking about, how do I build with this technology? What should I build? Do I make a company? How do I integrate this into my existing job? All that stuff. It's useful to think about what are the use cases that don't work really well today that could actually be unlocked by this new iteration of models. Like eventually there'll be new models from us and new models from other people, and hopefully they'll be better, and hopefully they'll unlock a bunch of these use cases. So it's worth pushing on the edges of what's possible today, so that you can start to get a perspective on what the next order of use cases are going to be, that this new technology is going to lock. So I'm really excited. It's always interesting to see. Like I think like the thing that's top of mind for me is like a lot of medical use cases don't work super well today because the model's not robust and reliable enough for those use cases to be like really, really great. And I think we're pushing towards a world where like, who knows, the next iteration of these models like might actually make it possible for, every doctor's office in the world to have AI helping aid the doctor and the patient journey. I think that's like a super exciting outcome, at least to me. And it'll be interesting to see what happens. Just to plant the seed on sort of where we're going, what we're looking at. I think there's a bunch of like core platform things that we're always trying to improve from the API side. So that's latency, rate limits, making things cheaper, all those things. And I think, folks hold us accountable if you think that in cases we're not doing that. I think from a pricing perspective, we've continued to drive down the cost for folks, which I'm happy about because it just makes it easier to build with our technology. I think, we just, and hopefully we'll have a tweet about this sometime today or something like that. But the rate limits for GPT-4 Turbo continue to go up, which is really exciting. So you can build more stuff and build use cases that require more AI, which I'm super excited about. And I think like the emerging angle is the ability to continue to customize models. So we have a fine tuning API. I think people have told us they want to customize models even more than what we allow in our fine tuning API. And I think we're doing a bunch of work to make that possible. So I'm excited for people to truly have like much more custom models and models that work well for all the different use cases that they're trying to build with. And then, as we saw yesterday with Sora, like lots of new modality stuff that's on the horizon with video and video understanding, video generation, all that kind of stuff. So I'm super excited to see where we go in that direction. I always like to include this slide as well anytime I'm talking to developers about building with our API. So it's important to remember that like we don't want your data when you're sending it through the API. Like we have no interest in using it. Like we want folks to be able to build on our platform and have the confidence to know that they can, build with us and not have to make that trade-off about their data. So your data is your data. It's not being stored or trained, or it's not being trained on by OpenAI. It is being stored in certain contexts for 30 days for safety purposes. But in general, we're not training on that data, which I think is useful to keep in mind. And I think it unlocks, in my mind, more use cases where you don't have to be as worried about about what's happening with your data when you send it to us. There's also, and I'll pull this slide back up when I pause for questions in a couple of minutes, but there's so many different like actual AI use cases / experiences. So as you're thinking about like, hey, I don't really know what I should be building, or I don't know what these models are capable of. This is a great slide if you want a screenshot of like all of the different places that you can use this technology to like solve real problems, like similarity and relevance for search, all the code use cases, tons of different like traditional machine learning use cases that require like regression or classification models you can now do with this technology. So there's a ton of different use cases. This is useful to come back to if you're thinking about like, I don't know what I should build with this technology, and I don't want to just make something really basic. There's a lot of cool stuff that you can do. All right. I really quickly wanted to talk about the Assistance API. So the Assistance API we released at Developer Day in beta. It is a sort of our first step into this world of building higher level abstractions on top of our API. What's really nice about the Assistance API is that you don't need to manage the conversation history. And there's a bunch of other features that I'll talk about, but the core premise is that you create this idea of an assistant. You can give the assistant different capabilities like code interpreter or knowledge retrieval or upload certain files to it. You can give it like a custom system message. And then that assistant can essentially handle many different conversations. So you can imagine you have one assistant and then you have your 10,000 users. Each user has a thread. The assistant sort of handles all of those different threads for you. You can also have like, let's say you had these 5 different AI use cases and they're all very, very different. You can have 5 different assistants and then you can sort of dynamically pass each thread to the right assistant. So you can write some code that has some really basic like switch statements or what have you that would dynamically dispatch the thread to different assistants. And the cool thing is that you can actually change the assistant as you go on. So you might imagine like in a customer support workflow, for example, you have like these different tiers of agents and of assistants. And if folks have gone through different customer support workflows, they're probably familiar with this, where like your first person is kind of there to like just generally help. And they might say, oh, you need to go to this other team, et cetera, et cetera. And they put you on hold and they do all this stuff. It's really cool because again, you can build sort of similar domain expert assistants. And then again, based on what the user is asking for, you can dynamically dispatch them to different agents and pass them around super seamlessly, which I think is really, really interesting. So it's worth keeping that concept in mind. And then the last piece of this is anytime the user adds a message or asks a question, you need to actually run the assistant. So when you do a run, you pass the assistant ID, you pass the thread ID, and that actually computes like the next turn of the conversation. Again, this is very different than chat completions, if folks have used that before, which is our sort of baseline API. In chat completions, you need to manage this conversation history yourself, which can be challenging in many ways. And you also lose some of those tools like code interpreter and knowledge retrieval, et cetera, are not functional with chat completions. They only work in the context of assistance. So assistance is definitely worth exploring. And I just included this slide as well, which sort of shows the state of what happens when you do one of these runs. So when you tell the model, hey, generate the next step in this conversation, or hey, go and do knowledge retrieval, or hey, write me some code and then execute that code and show me the output of it using code interpreter. This is sort of the flow of what happens. Behind the scenes. And again, it's useful to just keep in mind that there's like a little bit more complexity behind the scenes. And the idea is that that complexity makes it so that you can build much more expressive AI applications than you would otherwise be able to with something like chat completions. Um, that's pretty much all that I have to talk about. Super happy to answer questions about the assistance API or other things. I'll leave this slide up and then I'll go to try to find the chat to see if I can see any questions. And I might need help from the lab team to see where the chat is because I don't see anything in this active. Oh, it looks like there's a Twitch stream. Nice.
Yeah, so if there are some questions from the viewers, yeah, they going to drop the questions on the Twitch chat.
Yeah.
So
One of the questions that I'm seeing already is from Professor NYC. So the suggestion is to lean towards the assistance API instead of chat completions. In what case would chat completions make more sense? This is a great question. The chat completions makes more sense when you need to sort of control end to end what that experience is going to look like. So a good example of this is if you want to do like auto summarization of conversations and like all of this other stuff, like more advanced use cases, you actually need to do some of those with chat completions. And the reason for that is because with assistance, we abstract away some of the complexity of creating AI apps. And because of that level of abstraction, you actually lose a little bit of the customization. Again, it actually probably, if you're just getting started and you want to do some really simple use cases, it probably still makes sense to get started with chat completions and then move to assistance. But there's also, you can just do a lot more with assistance out of the box and like with less development. So if you don't want to do as much development, assistance is probably the place to start. And someone's saying, oh, I didn't know that OpenAI also supported speech to text. Yes, we have the Whisper model, which supports speech to text. We also do text to speech. Not yet available in the API, but hopefully will be soon. Oh, actually, it is available in the API right now. I apologize. We released it at Developer Day, so you can put in text and have it generate audio from that text. The question from Sparky, with GPT-4 Vision, is there an option to return the cost of what is in the image? You could ask the model to do that. If you're talking about like the cost to generate the image, like your cost as the developer building, that should be easy to do. If you're talking about like, here's a picture of a phone, how much does that phone cost? The model can do that. I think it's a question of like how good it's going to do at that. but in general, it should be able to. Flash is asking, how do we access GPT-4 for this hackathon? So most folks should have, I think if you have a credit card on your account, you get access to GPT-4 through our API. So you should be able to get access, and I think there's credits as well for folks to build. So um, hopefully those two things help. Another question, so I don't have to store all the thread messages in my database anymore. Exactly. So that's one of the cool things about assistants is that, again, if you set something up with chat completions, like you need to manage this conversation history, you need to manage a database to keep track of all those conversations. With assistants, you can just put everything into the threads, and then you still have to manage a little bit of this state yourself. Like you can't build like a stateless application, and that's because you need to know those like you need to associate in some way like the thread ID to a specific user of your application. So you would still, like if you have a database for your website, you would probably still need to have some information about the conversations being stored there, but it's likely to be the IDs for specific conversations, not like the entire conversation history, because the conversation history is being stored on our side and you can just access it through the API. Someone saying that ChatGPT has become lazy at certain tasks. This is what I was mentioning. We released a new model a couple of weeks ago, which should make this a little bit better. So the updated GPT-4 Turbo model and the updated 3.5 Turbo model should both take a stab at making this a little bit better for folks. Do you think you're going to be able to use image voice recordings to know if what we are watching is real or fake? I would imagine we have to do something like that, but not not accessible today. Is there a chance to grant early access to Sora? No, not yet. People are super excited about Sora, but we don't yet have early access for the general public. How can I enable the models to interact with presentations, like creating, editing slides using plugins? Do I need two small functions for every task related to interacting with a slide? Can add image to a slide, movie, etc. Are there comprehensive docs? So actually having the model like take action to like control something, it depends on like the interface that you're working with. If there's like a Python package that allows you to interact with a PowerPoint file, for example, or a Google Slides file, for example, you could actually write the function calling code to work with and modify that presentation just using function calling, just using the raw outputs of the model. If you're talking about like actually like using the cursor and like clicking and dragging, I think that will be a little bit more difficult, but there's definitely like, I've tried this before. There's like packages in Python, for example, that allow you to like modify Word documents and things like that. Can I use OpenAI files to store voice messages? Yeah, that should be, you'd have to double check what the supported formats are, and this is in our documentation, but we support a bunch of different file formats, so you should be able to do a lot of these things. The request always gives me the message an exception occurred. The model GPT-4 Turbo preview does not exist or you don't have access. That probably means that you haven't put a credit card on your account, and for various reasons, mostly to combat fraud, we make it so that you have to put a credit card associated with your account to get access to GPT-4 right now. So that's probably why you're getting that message flash. Is there cost associated to storing history of threads in the Assistants API? That's a great question. So you're not being charged based on storing the message history. You do get charged for storage of files. So if you upload, a PDF and you make that PDF accessible for retrieval, you would be charged for that. But the actual message history is not. You're not charged for that. There is a limitation on how long you can actually store data on our API. So like we're not going to store those messages like forever. So if you had some use case where you're like, I need to store these messages for 2 years, for example, you probably need to export those at some point and store them in your own database because it is like costly to store those files indefinitely. So we don't do that. It's not indefinite, but I think it's like 2 months or something like that. It's in our documentation how long we store those messages for. Are there credits for using, I'm guessing, OpenAI models for the purpose of the hackathon? Yes. I think this is most associated. Yeah, I think that's most of the questions. If I missed any of the questions, we have a developer forum, which is my last plug, community.openai.com. You can come in and ask questions about our API and all the good stuff to do there. So feel free to join. Would love to see the questions that folks have. I'll be online probably a little bit for the next few days answering questions. So feel free to ping me there. But this was awesome. Hopefully this was useful, and I will see folks on the developer forum if they have questions.
Thank you, Logan, and for your workshop and for answering almost all questions on the Q&A session, right? So I will not take any longer of your time. We have a new speaker coming up, and this is going to be, see ya. Yeah, and this is going to be Roy from PineCon. Roy is also developer relations at the PineCon, and let's see if we have Roy here. Yeah, we have him. Oh, cool. Now yeah, we cannot hear you yet.
Now can you hear me?
Yes, perfectly. Okay, cool. So Roy is going to walk you through the workshop about the RAG apps, and this is the retrieval augmented generation. So yeah, I'm passing mic to Roy. And yeah, have fun. You have 30 minutes of this session, and we're just going to be here if you need anything. Thanks.
Thank you so much. So let me start by sharing my screen. Okay, I can't share my screen. I'm gonna have to quit and reopen. I think it's on my side. I'm gonna have to quit and reopen. I'll be back in a jiff.
All right, so now we wait for Roy to come back, and that will happen in about a minute.
Okay. Okay, and we're back. All right. Sorry for the delay. All right. So today we're going to talk about retrieval augmented generation and how you go about building a retrieval augmented generation with Pinecone. Since I have 30 minutes, I'm hopeful to get to a little demo that will kind of walk us through how an application like this kind of actually operates in the real world. So let's start by just setting the scene a little bit and talking about what we'll talk about today. So I'll start by kind of level set and talk about embeddings, what they are, how they work. I'll quickly touch on what a vector database is and how Pinecone works, and then we'll jump into the meat of the talk, which will be about retrieval augmented generation. So we'll start with embeddings, and okay. We'll start with embeddings. And embeddings are essentially a representation, the internal representation of a machine learning model of the world, and specifically of particular relationships and features of discrete objects that it has been exposed to. Those discrete objects can be things like words, they can be things like documents, images, etc. And the relationships between those things are expressed in vector space. What that basically means is I could have multiple words that I'm going to embed, and then I'm going to be able to discern the relationship between those words by looking at the relationships between the vectors that they are projected into. The word embedding is basically the action of taking content from one space, for example, a semantic space, and projecting it or embedding it into a different space. And this is the vector space. If we had to visualize what embeddings look like in a very simplified way, we can see a 3D kind of representation of a vector space. And in that space, we see a set of terms. In this case, these are the days of the week. And because these terms have some sort of semantic similarity, they're going to be represented within the vector space as being close to one another. So that is what I was talking about in terms of the relationships between the vectors. The relationship is that they are physically, geometrically close to one another in that vector space representation. Now, of course, this is a very simplistic representation because vectors have many more dimensions. They don't have, they most likely don't have just 3 dimensions of representation. And so this is just to help us in kind of understanding the significance of what we mean when we say that vectors have some sort of geometric similarity. Now, of course, we're not limited to representing the meaning of words as standalone surface forms. Machine learning models and large language models are capable of representing contextualized meaning of words within a bigger context. So, for example, if we have these 3 sentences, where is the Bank of England, where is the grassy bank, and how does a plain bank, each one of these sentences uses the surface form bank, but obviously the meaning of the word is informed by the context. And so the representation within the vector space is going to be that the word bank, right, is actually different from sentence to sentence, again because the context informs us that the meaning is different. And then conversely, when we look at 2 sentences, the 2 sentences below, that each have completely different surface forms, but similar meaning, their positioning within vector space is going to be closer together. So the bees decided to have a mutiny against their queen matches the meaning of flying, stinging insects rebelled in opposition to their matriarch. And so that's where we would expect the meaning to kind of converge and the representation to be closer together. So now we understand what vector embeddings are and what they represent. Now let's talk about the vector database and what we do with it. So once we have embeddings, once we've created embeddings out of our content, whatever it is, again, documents, sentences, words, images. We need to store those embeddings somewhere, and the vector database is the place to do it. You want to use the right tool for the job. You don't want to store a graph in a relational store. You don't want to store relational data in a document store. And that's why you kind of want to store vectors in a vector database that was built natively to deal with the type of queries that are required to produce accurate, relevant results for vector similarity in a reasonable amount of time. So a vector database basically allows us to do this at scale. Like you would expect from any other database, it has those CRUD operations of inserting, updating, and deleting vectors as sort of a native action. The core capability is, of course, like I said, allowing us to retrieve those vectors, similar vectors, based on a query vector. And that will be based on some similarity metric that has to do with the type of use case that you're dealing with, as well as the model that you use to create your embeddings. And the last thing that vector databases allow us to do that is crucially important for RAG application is to associate a set of metadata to each vector that we store in the vector database. And we'll see exactly how that comes into play when we talk about RAG. Now, Pinecone, for anyone who doesn't know already, is a high-performance vector database that is distributed and fully managed. You don't have to care about optimizing your vector database. You don't have to worry about how to scale your database from whatever it is that you're currently handling towards the bigger scales of hundreds of millions and billions of vectors, because Pinecone will take care of that for you. And it will do that while maintaining very low latency and, of course, optimize performance and cost for all of your reads and writes. Okay, and now it's time to get into the meatier part of the conversation, which is retrieval augmented generation. So, a lot of people talk about LLMs and hallucinations, and hallucinations being kind of like the biggest problem that LLMs have. And I really love coming back to a tweet by Andrej Karpathy, ex OpenAI now, who wrote about this hallucination problem. And I'm not going to read the tweet. You can just do it yourself. But I'll just talk about the essence, which is LLMs don't hallucinate sometimes. They always hallucinate. What does that mean? It just means that we don't want to think about the LLMs as being a source of truth for anything that we do, but rather we want to think about them as being sort of a natural language interface or a reasoning engine on top of the source of truth that we may have. Hallucinations are not a bug in LLMs. That is the way they operate, right? They basically are, like Andrej Karpathy says, they're dream machines that we're able to sort of guide by using our prompts and by using our context window, which I'll talk about in a bit. But it kind of really requires us to think about our application in a little bit of a different way. And that's where RAG comes in. So LLMs don't know anything about our data. So they know about a lot. They know a lot about the data that they've been trained on. So any kind of general data that is available, open crawl, etc., is going to be available to the LLM. But the LLM is not going to care about, and it's not going to have any kind of specific affinity to the data that we care about. And it's definitely going to be more neutral, quote unquote, without any kind of focusing on a particular subset of data that we have an interest in. And like I said, this is why we kind of want to consider the LLM as not as the source of truth, but rather as a natural language interface or a reasoning engine. And we are going to have the responsibility of creating the knowledge base that will be the basis for all of the responses that our application is going to give the user. And the way we go about that is by building, again, a knowledge base, embedding that knowledge base, and then using semantic search and retrieval to inject relevant content into the context window of an LLM. Now, let's talk about the context window a little bit. Of course, barring really new advances that have been announced in recent days, the behavior of most LLMs up to now has been that they are limited in their ability to pay attention to the entire context window in a uniform way. In fact, what the Lost in the Middle paper shows is that there is this U-shaped kind of behavior where the LLM basically pays attention and is capable of retrieving accurate results in retrieving documents from the beginning of the context. And as we move towards the middle and end of the context, that ability drops dramatically. And so we still, even with a context window, we need to think about exactly how to use it because we don't have the assurance that it will be as effective throughout the entire context window. And so we have to really decide what is it that we're going to feed it, what content are we going to feed it, and where is that content going to be placed within the context window. And another example of how this can be removed. Another example of how this manifests, right, is the needle in a haystack test that kind of really shows us, right, the level of accuracy that models with very, very long context windows have, given that we're looking for a very particular set of information that may reside in different places of the context. So as we see, this diagram shows us that if we're looking at the beginning of the context, we have a much better chance of getting information from the top of the document and the bottom of the document. And as we move towards the end of larger and larger context windows, our chances of actually getting accurate retrievals from the top of the document sort of degrade over time. And then when we get to really large contexts, it's really, really bad all across the document. So the context window is something that we have to think about how to use and how to use effectively. And that is another reason why we want to start thinking about how to use this technique in an efficient way. And that's where vector databases come in again. So the process starts again with a user prompt that is going to likely be semantically ambiguous, right? So users are not going to know exactly what they are looking for. They're not necessarily going to know exactly what keywords to look for, nor do we want them to, because we're not building, Web 2.0 kind of search engines, right? Where we're relying on the user's knowledge and capability of hitting the right keywords. We want them to be able to be as free as possible when they're prompting our system. And so that's exactly where embedding models are going to be used to extract the semantic meaning of the user and to go beyond the surface form. And then we're going to be able to use that embedding to match semantically relevant content in a very precise and focused way to feed the information directly to from the vector database to the context window. This step also allows us to introduce this capability of saying, the LLM saying, I don't know, right? So when I'm querying my embedding, and when I'm querying my vector database with my prompt, with my embedded prompt, if the similarity score that I get back from my vector database is low, I can have mechanisms in my application to force the LLM to basically say, I don't know, because I cannot populate the context window with relevant data. I'm not just saying I'm going to take all of my data and stuff it and hope that the LLM gets it right. but rather I'm again introducing that mechanism that forces me to ensure that the relevancy of the documents that I'm pushing into that context window is in fact high enough based on my standards. So this is what the ingestion part of a RAG architecture application looks like. We start with a data source. Our data source, let's say, would be a set of documents. Those documents need to be chunked, meaning I don't want to take the entire document and embed it, because my ability to then target that document effectively to make it a relevant portion of my context window is going to be limited, because it might include too much information, and that basically will mean that a lot of different prompts with different semantic meanings may hit that same portion, may hit that same document. And for that reason, I'm trying to reduce the size of those units that I'm actually going to embed. So once I've done that and I've created smaller chunks of these documents that come from my data source, I embed each one of those chunks. I then take those vector embeddings, I can associate them with whatever metadata I may choose, and then I upsert them into the vector database. And that metadata will most likely be things like, if it's a URL that I retrieved the information from, it would be the URL. If it would be a parent document from which I've chunked, it would be that ID for that parent document, and so on and so forth. This is all in a goal. The goal for this is to be able to refer to that original information where the chunk was created from, and the match is given to be able to refer back to that in the application. And I'll show that in a minute in the demo that I'm going to walk through. The other side of the coin is the application. So as I mentioned before, we take the user's prompt, essentially the query, we embed that query, and we can use any metadata filter to filter down our results if we so choose. We take that vector embedding and we query the vector database using that vector embedding, and we get back our query results. And those are going to be essentially the chunks that actually have the semantic relevance to matter, right, to our user's prompt. Once I do that, I can take those results, put them in the context of the LLM. That context is given to the LLM, and then the LLM can stream back a result that is readable and easily consumable by the user. Okay. One slide I have here before we move on to some additional info and a demo is the RAG ecosystem. So, I mentioned, the different parts that the different steps that you have to take in order to build this RAG application. It's worth talking a little bit about the different tools that you may use to accomplish this task. So, you can think of like I said, any kind of RAG application as having two major portions: the ingestion and then the application. The ingestion pipeline, we've seen people use tools like Pinecone Canopy, which takes care of all of these different steps from the data source through pre-processing, segmentation, or chunking, and embedding up to upsorting into Pinecone, and handles the entirety of that ingestion pipeline. For larger scale use cases where you're handling hundreds of millions of documents or potentially billions of documents, we've seen people parallelize this process using tools like Databricks and Anyscale. In terms of document pre-processing, for example, I have a set of PDFs and I have to extract those PDFs, extract the text from those PDFs, or do some sort of pre-processing to those documents. We've seen people use LangChain and Llama Index. Document segmentation, also the same. LangChain and Llama Index are kind of like at the forefront of providing easy tooling for doing that. Embedding generation, this is obviously like a very partial list from OpenAI, Cohere, Hugging Face, Anthropic, Haystack, SageMaker, and OctoAI. All of those are embedding generation providers that you could use to accomplish the embedding task. Then you can create the index and update the index either using the Pinecone SDK directly or by leveraging the abstractions that are provided by LangChain and Llama Index. And then on the application side, we have 4 main steps that are kind of like the cornerstones of most RAG applications. Of course, there's the retrieval step that we've discussed, and that will be done either by the Pinecone SDK directly or by LangChain and Llama Index that both provide abstractions on top. Embedding generation is the same, so I'm not going to repeat the list again. There's a potential step for re-ranking our results that you can read more about in our website. Cohere is currently I believe the only one that is providing a model for re-ranking particularly. And of course, there's a UI component that ties it all together. And we highly recommend using Vercel for those purposes, mostly because they already have a lot of tooling around creating a very easy and straightforward kind of like chat interface with streaming back and forth that makes your job as a developer a lot easier when you're building chatbot applications at the very least. Before I jump into the demo, there are a lot of different considerations that we can talk about in a lot greater detail. And if you have questions about them, I'd be happy to talk about. But I thought that I'd mention several of them here, things that you kind of want to keep in mind before jumping into your implementation. First, you kind of want to think about your chunking approaches. So the naive thing to do, the immediate thing to do is to go to what's called the recursive chunking strategy, which basically allows you to chunk your data in more or less fixed sized chunks. That may work in a lot of cases, but may have some adverse effects if your text can be sort of cut in the middle. And if that happens, in certain cases, for example, if you're indexing a documentation website that has a lot of code examples, that may be a problem because you might be cutting through these code examples and breaking them and making them sort of incoherent. And in that case, you might want to consider using other approaches like markdown chunking, which I'll present in a little bit when I show the demo. Parent document retrieval is a very common pattern to make it so that the LLM has a better chance of actually providing a correct answer. So after you've created your chunks, like I said, you have some reference to the parent document that the chunk was created from. And instead of just providing the LLM with the particular chunk, you actually provide it with the entire document. And that, again, increases the probability that the LLM will answer the user's questions correctly. Multi-query generation is a technique that a lot of people are using now to make it so that there's a better chance of actually getting a relevant retrieved document. The assumption here is that the user doesn't necessarily know what they're asking or how to ask it in the best possible way. And so you apply LLMs to generate additional queries that you can then use to match on your embedded knowledge base. Hybrid search combines the ability to use dense and sparse vector retrieval, again, to improve upon use cases where domain-specific keywords are being used that are not going to be known to a dense embedding model. And there are more, but I really kind of think that I'm running out of time, and I want to just run through this demo really quickly. So in this demo, I'm basically running through this entire process of retrieving, of indexing some documents, embedding them, chunking them, embedding them, and then doing the retrieval with the reference to, whenever a question is answered, the answer will include some reference to the original document or the original chunk where that where that answer was based on. So you can try it out now yourself in Pinecone RAG demo Vercel.app. It's also available on GitHub for you to extend and use. It's completely open source. So I click on embed and upsert, and basically it's going to take this URL and go through the embedding and the upsert process. Here I have in the bottom here the various chunks that were built out of this particular URL. And if I ask a question like, how are robots learning housework? You'll see that I have two chats, one on the right and one on the left, one that uses OpenAI in and of itself, and one on the left that uses OpenAI plus Pinecone RAG. And the biggest difference, there's going to be a substantial difference in the actual answer. The answer on the left is going to really focus on the content of this particular story and the portions of it that relate to the question. And as you can see, I have the particular chunks that have been used in order to compose the response. You can play around with different chunking methods, try different URLs, and even change these models out to use other models that are OpenAI compliant. We've seen that with OctoAI, that kind of built their own demo that used a whole set of different open source models like Mixtral, et cetera, to kind of see how they work side by side. And I think that is it. We have maybe a minute for questions.
Thank you, Roy. So yeah, let's see if we have any questions in the chat from the stream. Let me just quickly check it. Okay, guys, can you hear me?
Yep.
Okay. Mm.
Yeah, absolutely. All right, thank you so much.
All right then. Now moving on, and we have the new speaker, Josh. Josh is a DevRel engineer from TruEra, and he's going to lead the workshop about the advanced methods of evaluation, by TruLens. So I'm passing the mic to you, and have fun with the presentation. See ya.
Awesome. Thanks, Katya. Really always great to hang out with the Lab community. You guys are always a ton of fun, and I can't think of kind of anywhere else I'd rather be on a Friday afternoon. So really glad to be here. And I also want to kind of thank both Roy and Logan. So really awesome workshops you gave. Really empowering the community to go forward in this hackathon and build some pretty awesome LLM maps. So in this talk, I'm going to be kind of going through some advanced evaluation methods with TruLens. I think a lot of this community is already really familiar and has started to use TruLens in some past hackathons, especially with focus on the RAG triad. So in today's talk, I'm hoping to kind of inspire you on ways you can really go further in improving your RAG or LM applications. So on the agenda, first I'm going to do a brief overview of just why we need evaluation in the first place. And then from there, I'll go into how to evaluate hybrid search. And then last, I'll touch on evaluating summarization use cases. So to first, why do we need evaluation at all? It's because looks good to me is not a metric. When teams often start building these LM apps, they may use subject matter experts or have some kind of human evaluators that say, hey, this LM response looks good. But really we need to be able to kind of quickly iterate and really understand how our application is performing across kind of a range of different aspects. We need more of a standardized systematic metric so that we can track. And that's where TruLens comes in. So TruLens is an open source project to track and evaluate LM experiments. A lot of you guys have already used it in past hackathons. And what this gives you is the ability to develop a set of metrics so you can really evaluate the performance of your application each time it runs. And from the wise words of Greg Brockman, the president of OpenAI, evals are surprisingly often all you need. And this really gives you the power in your hands so you can know how your application is performing. And as we move into 2024, we did a pretty recent survey back in November to see how many folks had started to move their applications into production. And the overwhelming majority were still stuck in this 0 category and had not yet moved apps to production, and we're still kind of in this development environment. And the top reasons they cited for doing so were concerned around quality and hallucination, things like governance and security, and costs. And these are kind of representative across all kinds of different apps. So chatbots, advanced RAGs, agents, multimodal apps, and a whole bunch more. And over this time, we've seen a really big surge in the adoption of our open source TruLens, and then also Gen AI customers that are seeking to bring evals and have a systematic way of evaluating these apps so they can get into production faster. So now that we've kind of touched on why we need evals, I want to get into a really concrete use case that I think you'll probably be focusing on over this hackathon, especially because we have kind of great experts on the search and retrieval and vector database portions with the Pinecone team on hand. So just to give you a quick primer on hybrid search is the kind of the combination of different search methods that may have different strengths and weaknesses, so we can get a combined search result that maybe outperforms any individual retriever on its own. So typical semantic search methods are what we call dense. So this means that the semantic search is returning the most similar results according to a particular distance metric. And that's because the vectors that represent the documents numerically represent the semantic meaning through embedding models. So embedding models like ADA2, for example. And then on the other hand, more traditional search methods are often sparse. So sparse vectors are really big. They have a lot of dimensions, but most of them are 0. So in keyword search, you can think about each different value representing the presence or importance of a particular possible word, and then the value representing how important that word is in the document. So hybrid search is the combination of different search methods, such as dense and sparse methods, to get this combined result to provide it to our kind of end user. So to give a really simple example here, I put together a really small kind of vector store with a few sentences about apples, a few sentences about oranges, and then I'm searching for the word apples in this really tiny toy vector store. So my dense method, which is the face, returned both you like apples and you like oranges. And then BM25, which is my sparse method, returned I like apples and oranges are fruits. So when I do the ensemble that combines both of those results from each search method, I get all 4 results. So I get you like apples, you like oranges, and apples are fruit. And then by bringing in TruLens, we can also understand how did each of these evaluation or each of these retrievers perform. So here you can see with the evaluation scores that the face returned one relevant document or a piece of text. Same for the BM25, although the second text was a little more relevant than it was for face. And then the ensemble obviously retrieved all of these, so we can have evaluation scores for each retrieved context chunk. But what's missing here? So maybe there's a couple of things that we could do so we don't have to just get everything, but maybe we can just get the best stuff. So one thing we can do is re-ranking. So given all 4 context chunks, maybe we can say which context chunks are the best and which ones should we provide to maybe our LLM in a RAG setting or just our user in a search alone setting. So when we re-rank, we can re-rank using a couple different ways. So we can use an embedding model or a re-ranking model that is such as like BG small or maybe something from Cohere. There's kind of a whole bunch of different re-ranking model providers. And we can also just use the feedback values themselves. So in this case, we can use the context relevance score, 1, 0, or 0.5, do the re-ranking, and then we can say, hey, this I like apples and you like apples are the best 2, and then the apples and oranges are fruits is the kind of the 3rd best retrieval, and then we have you like oranges as 4th. And then from there, we can filter to let's say the top 2 re-ranked results across both of the different retrievers. So really by combining the hybrid search, the re-ranking, and then the filtering, this gives us the best possible result that we couldn't get with either of the individual retrievers alone. So now by combining kind of these different ideas along with evaluation, we have really good retrieval and we have verified that it's correct. So what does this look like in kind of more of a real life example? So here's kind of the call stack of different traces of a LLM application that does a lot of these different things. So here we have 2 component retrievers, the BM25 and the vector index retriever. We have this kind of top rectangle base retriever that is kind of the hybrid component that combines the results of both retrievers. And then last we have the re-rank and filter, which is this post-process nodes portion of the app. Then the other thing you'll notice, if we just look at the timeline over to the right side of the page, is that the BM25 retriever is really fast. So you can see it takes a really short amount of time, just 76 milliseconds. The more dense retriever, the semantic search, takes a bit longer. So this one is taking around 539 milliseconds. And then by far the longest piece of this application is kind of the re-ranking and filtering. But if this gets us better results, then maybe it's worth doing kind of all of these different steps to get the best possible search to pass to our LLM. So how do we know which retrievers are effective? I think you probably have an idea of this from the kind of first toy example we went through. But to make this more concrete, we can point to all of the different retrievers and pieces or components of our application, and then we can evaluate them. So how do we do that with TruLens? So here I'm showing kind of a quick code block on how to evaluate the BM25 retriever. So here, what I'm doing is I'm setting a fine-grained feedback selector to the BM25 retriever. So you see it, we have BM25 context, and then we have our lens of the call stack. So this is the location in the call stack in which the BM25 retriever is being used. And then from there, we can drill down to get exactly the text from that BM25 retriever. So the text that it's retrieving. And then from there, now that we've set the context, we can just pass it in to our context relevance feedback function and evaluate the relevance of the BM25 value or retriever. We can also evaluate the ensemble. So the context is going to be pretty similar to the BM25, except now you see we've changed the selector or the feedback selector for a hybrid context to just the base retriever. So if we kind of go back a little bit, you'll remember this was this overall kind of overarching retriever. So that includes both the results from the base retriever and also the vector index retriever. And then the last thing we can do is we can also evaluate the quality of the re-ranking and filtering. So here, what you can see is that we've now moved to select the results from the post-process step of our application. So just like the other two evaluations, now we can see how good is our final post-process results. And now that we've done that, we can see which evaluators should we have used to start with. We have evaluation results shown in TruLens, where we have run a few queries and used the kind of this whole stack of retrievers. And so we have results on the hybrid, the BM25, the hybrid filtered, and the vector search. And maybe what this says is that for this case, maybe we should have just used the vector search alone. So maybe the hybrid search or the hybrid filtered search, while has a good score, we would have been both more efficient and maybe just as good with the vector search alone. So now that we've covered the hybrid search, the next thing I want to get into is how to evaluate for summarization use cases. So to think about this idea, I wanted to kind of really take this from kind of an elementary school level and say, what do we include in a good summary? So a few things that the kind of elementary school teacher says here is we should always include the main idea. We should include the main fact or facts. It should be in your own words. So the LLM is really powerful at that because it's not only just giving you the exact text from the source document, but it's also able to summarize it and put it in a style that you ask. And then we also want to make it short. So in the LLM context, there's now kind of two sides to a good summary we can think about. So the first is it accurate? Is it hallucinating? Is it only providing things in the summary that were present in the original source document? And then the second is the summary comprehensive? So are we including all of the main facts or the main important things from our original source text? So this was kind of the key piece that we learned from the elementary school teacher. So if we now consider a meeting summary, so here I went and found a transcript from a meeting from the CTAS county submission, which is kind of some government commission in Tennessee. And then I provided that transcript to ChatGPT and asked for a summary. So here's what I got. But wouldn't it be really great if we had a way to know if this is actually good, if this provides kind of the key facts and doesn't hallucinate and is kind of the right sort of summary that we're looking for. So using TruLens, we can do exactly that. So here you can see the evaluation result of this summary, and then you can also see both the criteria of what are the key points from the source text that we should have included in the summary, and then also the supporting evidence that says that the summary includes all key points from the source text, including specifically that it was called to order by the chairman, Some different motions were made and discussed. A resolution to increase a wheel tax was passed, and announcements were made. So maybe from here we have a kind of a different summary that we also want to evaluate. So here you can see kind of a slightly different version of the summary. And now let's kind of do the same thing and pass it to our LM evaluator. And now the LM evaluator is providing a score of 0.8. So the summary is still pretty good, but maybe it's missing a few things. And what you see when we look at the criterion supporting evidence is that the supporting or the summary does not mention the amendments specifically that were proposed and debated. So there's kind of nothing about the wheel tax that we saw in the first summary. And summaries can also contain hallucinations. So here we can think about a transcript from a kind of hotel room service where the operator and the customer are kind of asking about the status of their room service order. And then the LM summary is kind of interjecting this kind of opinionated claim that they're not happy about the wait, but there's not actually clear, direct supporting evidence from the original transcript that provides that. So here's kind of a nice example of hallucination that can happen when we're doing a summary. So now that we've kind of gone through these kind of more advanced ways to evaluate LLM apps, whether we're building complex retrievers such as hybrid search, or we're using summarization apps, we can really go a lot farther than only the RAG triad, and we can kind of really use evaluations to drive the quality of our application and make different decisions on which retrievers we should use, how should we develop the summary, and a whole lot more. So from here, I think I just want to pass it back to Katya and say it's now time to go forward and make production-ready apps. So enjoy the hackathon. Back to you, Katya.
Hello? Hello? Can you hear me? So we are ready to move on, yeah? Cool. So awesome. Josh, thank you very much for the presentation, for your session. And since we are a little bit earlier and we are done with our speakers for today, so we can move on to the general Q&A session on Discord. So this is the kind of Q&A which will be led by the mentor leads on the Q&A stage on Discord. So please shoot all of your questions there. And yeah, I wish you a great rest of your day, and we will see you on Monday during the next workshop that we also have prepared for you. Thank you, guys.